Dear students, in this video I am going to take a practical example of how to classify a tissue paper as a good class or a bad class with the help of a KNN algorithm. So I am going to teach you that. Here you have a data questionnaire. It is a survey from the people, and the survey is based upon two attributes. One is acid durability and strength, and to classify whether a tissue paper is good or not. So these are the four training example. Now there is a new tissue paper and whose acid durability, you can see it here, your acid durability is x1 equal to 3 and x2 equal to 7. Strength equal to 7. So these are the two parameters, and with this two parameters a tissue paper has come to pass the laboratory test, and we need to classify whether it is good or not. So when you see this example, x1 and x2, here it is 7 7 7 4 3 3 4 and 1 4. So these are the training examples. These are the training examples. Okay. So now what is the new query which has come in xq? xq is 3 comma 7. So what we have to do is we need to find the distance of this data point with each data point. Okay. So how will you find the distance? Like 7 minus 3 the whole square plus 7 minus 7 the whole square. Again 7 minus 3 the whole square plus 4 minus 7 the whole square. It is vice versa. Next 3 minus 3 and 3. So 3 minus 3 the whole square plus 4 minus 7 the whole square, or here you take it as 4 minus 7 the whole square, and again 1 minus 3 the whole square plus 4 minus 7 the whole square. So when you calculate this, this is going to be 7 minus 3 is 4 square 16, so this is 16, and now this is 4 square plus 3 square, which is 25, and this is 0 and 3 square, which is 9, and this is 2, this is 2 square is 4, and 4 plus 3 square is 9, so 30. Now you have found the distance, Euclidean distance, and after finding the Euclidean distance you need to rate, you need to give rank. So this is the nearest neighbor, so this is the weight you are going to give. This is the nearest neighbor, this is the second nearest, this is the third nearest, and fourth nearest. And now we are going to take our hyperparameter k equal to 3, that is we are going to consider only the first three neighbors. So this is an assumption, always remember you are going for an assumption. If we take k equal to 4, then there will be a tie and you cannot go for a particular classification. So this is the reason that we don't go for even numbers. So k cannot be an even number. Okay, so k equal to 3. So when you take k equal to 3, I am going to consider only these three cases. So how many instances will be classified when I consider 3? This and this and this will be selected. Okay, this will be selected, and this will be omitted. We are not going to consider. So now for example, we have given the target. So this particular example is a bad tissue paper example, and these two are classified as good tissue paper example. So when you see the majority, of the nearest neighbor, there are two positive examples and one negative example. So your xq, it will belong to your positive example. So tissue paper with the acid durability 3 and strength 7 will be classified as a good tissue paper. So this is one particular example of your k nearest neighbor algorithm. One a very small example, with a very small data set. Another one is here. So here we have the weight, height and t-shirt size of some customer, and we need to predict the t-shirt size of a new customer. For example, Usually when we were studying in school, people used to take your sports uniform measurement with the height, weight, and they will also ask for your t-shirt size. Similarly, here they have classified height and weight, and they have classified the t-shirt sizes medium and large. And now there comes a new customer. This is a small data set. Now we are going to we are a many function, but we go for Euclidean, which is the most common one, and Manhattan is very common for continuous variable. Continuous variable is you're going to find a value of something, find a value of t-shirt price. So you're not going to go for discrete value. So if you are going for discrete value, then Euclidean distance will be the most common one. When you go for the for finding real value or continuous value variable, then you go for Manhattan distance. So you know the formula of Euclidean distance. This is your Euclidean distance formula: xi minus y the whole square. That is the distance between two data points. Now there comes a new customer, Monica, whose height is 161 centimeter and weight is 61 kg. So what we do here is they have implemented with the help of Excel. So they have a substituted formula for one particular cell called as. So you see the first cell. The first cell, your height is 158 and weight is 58. So Monica's height is 161. So 161 minus 158, 3 square, and again 3 square. So 3 square plus 3 square will be 9. So similarly we have to calculate the distance value, and we have to find the nearest neighbor. So here they have implemented with the help of Excel sheet, and they have applied the formula, and they have found that here we have assumed k value to be 5. So they have taken first 5 ranks. First 5 rank. Here there are two variables which have same distance value, so they are given the same rank, and the fourth value is omitted. Fourth value is omitted. So which is the first one? 1.4 is the distance is 1.4, and it has been given the highest weight value, that is first rank. And so your Monica's t-shirt will be classified as a medium size t-shirt. So you see, when you see the classification of all the 5, there is only one large point, and all the other 4 classifications are medium point. So your Monica's t-shirt will lie along your blue. Here the blue represents your medium, and orange represents the large t-shirt size, and this Monica's weight and height value is residing among the height and weight values of the medium size t-shirt size person. So this yellow color, this Monica's particular query or the new query instant will be classified as a M size. So now what we have to do is sometimes we have to go for standardization. So when independent variables are measured in different units, we need to standardize the variable. So instead of going for x minus mean by standard deviation, what we do here is x minus minimum value divided by maximum minus minimum. So when you go for standardization of the values, then what happens? See, now there are no same value here. You can have ranking, you can have different ranking, 1, 2, 3, 4 and 5. That's why you go for the fifth closest value got changed as height was dominating earlier. Height was dominating earlier. Now you have standardized both height and weight are in negative, and you see everything in decimal value. In the first case, height was in hundreds and weight was in like 50, in the range of 50s. But now everything is standardized, and you can see the positive and the negative value, and because of which there are 5 distinct ranking, and you can go for a sharp classification of your data. So this is all about your KNN algorithm, nearest neighbor algorithm. Students, I hope, I trust that you people have understood it in a better way. Thank you.